Hi everyone. So in the last video, I basically went over how any row of Pascal's triangle can be determined through the combinations, of the forms that we've written over here. So let's try to use this now for binomial expansion itself, which is the topic at hand. So let me just take a new page. So say for example, I have x plus 1 to the power of 5, okay? And what this is equal to, I'm just going to write what this expansion is equal to, so you don't have to do it by yourselves. I'm just going to write what it's down. So it's 5x to the power of 4 plus 10x cubed plus 10x squared plus 5x plus 1. So you should observe two things over here. You should observe two things. The first one is that this row 1, 5, 10, 10, 5, 1 was basically like the row of Pascal's triangle that we observed before. The second thing to observe is that we have 5, 4, 3, 2, 1, and then x to the power of 0. So in other words, the powers are decreasing for the variable, okay? So what's really happening? So let me show you what's really happening in the background in order to determine this. So what this is actually equal to is, it's actually 5 choose 0, which is the first term. Remember, 1 was 5 choose 0, okay? And this term right here is x, the first term, and it's to the power of 5, and then the second term is 1, which is 1 over here, it's to the power of 0. Okay, so observe, I still have more to write, but I just want you to observe a couple of things. That, remember, the first term that we have, we say it's 5 choose 0, not 5 choose 1, but we start off with 0. Our index starts from 0. Okay, and it's 5 over here because we have to the power of 5. Okay, the second term, if you can guess, must be 5 choose 1, right? And then once again, we have our two terms, okay? X is our first term because that's the one over there, and 1 is our second term, which is over there. The power over here must decrease. So this power over here is 4, and these two powers, if you observe over here, 5 and 0, 5 plus 0 is equal to 5. So these two powers must sort of add up to 5 as well. So the power for 1 becomes to the power of 1. And you can observe another thing that, for example, this term over here, this 0 over here, is also the same term as the last term over there. So you can use that if you wish. That's another way of sort of determining what the terms are. So let's try the next one. So in other words, so we're done with this, let's do this one. So this should be, so 0, 1, 2. So this should be 5 choose 2, right? And the power is decreasing, so this should be x to the power of 3. And this term is now 1 to the power of 2. And once again, if you observe, this term and that term are exactly the same. Now let's go, so we're done with this, let's go to the next term. So this should be 5, so 0, 1, 2, 3, so this should be 3. So even though it's our fourth term, 1, 2, 3, 4, because we index it from 0, the number that we put here is 3, so 0, 1, 2, 3, right? So this is x, this is 1. This power should become 2 because it's decreasing, and this power should increase to 3, right? Because the two of these should add up to 5. Okay, so we're done with this one, and let's go to the next one, which is 5 choose 4, and this is x to the power of, x to the power of 1 because it's decreasing, and the next one should increase, so 1 to the power of 4, and then finally the last one is 5 choose 5 is x to the power of 0 times 1 to the power of 5, right? And basically 5 choose 5 is 1, x to the power of 0 is 1, 1 to the power of 5 is 1. So if you multiply these together, you will get 1. So that's basically what's happening in the background. So in other words, this counting term right here, it counts how many of the x to the power of 5s we have, right? And also multiplied by the second term. This counts how many we have, and so on and so forth. So we've involved our counting term in each of these terms, and we've also taken care of the powers as well for each of these terms. All right. So let's use this concept to help us sort of expand another sort of binomial. Okay. So let's do this example. So 2x minus 3 cubed. Okay. So we see that's to the power of 3. Okay. So remember, our index starts from 0. Okay, so we have 3 choose 0, okay? Our first term goes here, our second term goes here. So our first term is 2x, our second term is negative 3 because it's negative 3 over here. So what power should we put this to? This should be to the power of 3, right? Because we have the highest power over here. So whatever the first term is, just put the same power. The second one should be 0 because these two should add up to 3 because of the power over there. What's our second term? It should be 3 choose 1. It counts for us how many of the following terms that we have. So again, we put the same terms over here. So 2x and negative 3. Now this power should decrease. So this becomes squared and that should become 1. Okay? We have two more terms to go. So we have 3 choose 2. And I just like to write this out. So 2x negative 3. So this becomes 3 to 1 and 0, 1, 2. So these two should add up to 3, right? And finally, our last term is 3 choose 3, right? And we have the same terms over here, 2x and negative 3. Remember, 2x comes from here and negative 3 comes from here. And what power should this be? Since this is decreasing, 3, 2, 1, the last one should be 0. And what power should the second one be? 0, 1, 2, 3. Okay? And so let's basically get what each of these are. So 3 choose 0 is actually 1. Okay? 2x cubed is 8x cubed. And negative 3 to the power of 0 is simply 1. Because anything to the power of 0 is 1. Next term. This 3 choose 1 is actually 3. Right? 2x squared is 4x squared. And this negative 3 to the power of 1 is simply negative 3. The next term, 3 choose 2, is also 3. Okay? 2x to the power of 1 is simply 2x. Okay? And negative 3 squared is 9. Now the last term, 3 choose 3, is actually 1. 2x to the power of 0 is also 1. And negative 3 to the power of 3 is actually negative 27. Okay, so we have one more step to go. So we're almost there. So 1 times 8x cubed times 1 is simply 8x cubed. 3 times 4 is 12x squared. And 12x squared times negative 3 is negative 36x squared. Okay, this one is 3 times 2x times 9, so 6x times 9, which is plus 54x. And finally, the last one that I have here is minus 27, because 1 times negative 27 is minus 27. And that is how we expand 2x minus 3 cubed. It's simply equal to this. Okay, let's try a couple more examples just to make sure that you get it. So let's try something with a higher power. So let's try 4x minus 3 to the power of 4. So once again, right, write these three things down. Okay, so we know the first, it's to the power of 4, this 4 over here, right? And our index starts from 0. Okay, in this term, it'll be 4x because that's the first term of the binomial. And the second one is negative 3. And remember, we start with the highest power for the first term. So it's 4 because that's the maximum power it can be. And for the second one, it'll be 0. Okay? Then we can just continue. So I just like to write these three brackets so that way I know I'm never going to make a mistake. So this is going to be 4. The next index is 1. This has to be 4x, and that has to be negative 3. This is to the power of 3 now because it decreases. And the next one has the power of 1 because it increases. Let's do the next one. So 4 choose 2, right? Because the next index is 2. 4x is here, negative 3 is here. Now this power will be squared, and that power will also be 2 because this one is decreasing and the next one is increasing, 0, 1, 2. We have 4 to the power of 3. 4 choose 3, my mistake. 4x, and then it's negative 3. And so what power will this be? This will be 1 because it's decreasing, and this will be 3. And so a good way to making sure that you're correct is always these two, 1 and 3. The powers here should add up to whatever power you're raising it to. So in other words, 1 plus 3 should equal to 4. And finally, it's 4 choose 4 is 4x, negative 3, and this is to the power of 0, and that's to the power of 4. Okay? So now that we have this, we just have to expand this. Or not expand it, but I mean basically get it to its numerical sort of form. So 4 choose 1, that's 1. 4x to the power of 4. So 4 to the power of 4, if you don't know, is 256 x to the power of 4, and negative 3 to the power of 4 is 1. The next one here is 4 choose 1 is actually 4. 4x cubed is 64x cubed, and negative 3 to the power of 1 is negative 3. I'm just going to scroll down just a little bit so I just have some room. So plus this term right here, 4 choose 2 is actually 6. 4x squared is actually 16x squared, and negative 3 squared is 9. The next term is 4 choose 3 is actually 4. 4x to the power of 1 is 4x, and negative 3 cubed is actually negative 27. And finally, the last one is 4 choose 4 is 1. 4x to the power of 0 is also 1. And the last term, negative 3 to the power of 4, is actually 81. Now, I doubt they will ever make you, in the IB exams, or any other exam for that matter, make you actually do to that many powers, but this is basically how you do it. If you're given a calculator, then it's even easier. So finally, this term, the first term, it's 1 times 256 x to the power of 4, so it's really 256 x to the power of 4. The second one is 4 times 64 times negative 3. So I've basically done this beforehand. So this is negative 768 x cubed. The third term is 6 times 16 times 9. That's going to be plus 864 x squares. Right. The next one is 4 times 4x times negative 27. That's going to be negative 432x. And finally, the last term is going to be plus 81. And that's how you do that binomial expansion. Let's do one last one just to make sure we get the concept. Okay, so this is 3x minus 2 cubed. Okay, so once again, do the choose and write each of these terms. So it's 3 choose 0. The first term is 3x. The second one is negative 2. This is going to be to the power of 3. That's going to be to the power of 0. The maximum one first. This is 3 choose 1. Again, 3x negative 2. This is going to be decrease 1 power, and that's going to increase by 1. It's going to be 3 choose 2. That's going to be 3x. That's going to be negative 2. And that's going to decrease by 1, and the other one's going to increase by another. And finally, 3 choose 3 is equal to 3x, and that's going to be negative 2, and the power over here is going to be 0. It's going to drop, and that's going to be its maximum. The second one is 3. So let's find what each of these are. 3 choose 0 is 1. 3x cubed is 27x cubed times 1, plus 3 choose 3 is 3. 3x squared is 9x squared. Negative 2 is negative 2, plus 3 choose 2 is 3, 3x is 3x, negative 2 squared is 4, and the last one is, this is 1, anything to the power of 0 is also 1, and negative 2 cubed is negative 8. And so finally, what this is the first term is 27x cubed. The second term is 9 times 3, 9, 18, 27, 27. So it's negative 54x squared. The third one is 9 times 4, which is positive 36x. And the last one is minus 8. All right? And so that's how we do binomial expansion. And just to keep in mind, once again, the reason why we have these choose terms, these combination terms, is because they count how many of the following terms that we have here. And it's just a convenient way of how it does that, and that's basically how we can do the binomial expansion. So in the next video, I'm going to explain some of the uses of binomial expansion and how we use it in sort of everyday things.